Hello everyone. In this video, which is my second element safety video, we'll talk about this giant group of gases called noble gases. Last element safety video, I talked about gallium and some of the puffery in its SDS'S. Today, we'll talk about noble gases. There's not that much puffery, but still. Well, technically there isn't really puffery, but there's a couple important things about these gases that I want to point out in this video. First of all, noble gases have completely filled orbitals. That means it will not accept extra gas floating around or anything. It doesn't bond. You could pump however many other atoms you want into CU noble gases, and you'll really not get anything other than a bunch of other atoms that are bonding together and doing weird stuff, while the noble gases are just sitting around there doing nothing. Also, note that you should not confuse noble gases from noble metals like gold and silver. Those are completely different, and they have free electrons, and they bond with other compounds. Noble gases don't do that. So just keep in mind the definition of noble there. Okay, first of all, we're in for our first noble gas, helium. Oops. Okay, our first noble gas is helium. Helium is a special noble gas because its nucleus is also referred to as an alpha particle, and it is actually one of the decay products of atoms. Atom decay products are alpha particles, electrons, positrons, which are antimatter electrons, and gamma radiation, along with daughter nuclei in the case of spontaneous fission. Here we'll look at here we've two SDSs for each noble gas. Of course, we're ignoring a Ganosean in this case because it's not valid. Too radioactive, too synthetic. Okay, now let's take a look. SDS, helium, air gas and air liquide company. I actually have some air liquide stuff, but I'm not sure why air liquide because. Okay. Now, there is one good point I want to make. May displace oxygen and cause rapid suffocation. This is pretty true for most gases. One time I saw a balloon and it had a label on it telling you not to pop it for some reason because it will displace the oxygen in the air. Xenon, like this noble gas xenon, is sometimes discussed as an anesthesiant. Literally, that's how. Okay, now here's the problem. Gases under pressure. Of course, you could have free floating helium or any noble gas and you'd be fine. But to store properly, you need to put it under pressure. This is even more important for helium because helium is the smallest atom in the whole periodic table. It'll just slip through. It'll just slip through the microscopic holes in the glass. In case you're wondering why I said holes in the glass, it's not because it cracks. It's because the silicon dioxide molecules, aka quartz molecules, along with the lime that's mixed in the quartz to make glass, there's still nanoscale holes in between because the atoms can't fit the whole structure. In case you don't know what I'm talking about, turn to spear packing. Okay, with spear packing asides, it's you can see how all of these stuff is Na. The reason is gases they tend to float around the space they have. And always, this space is defined by a solid environment. Say if you take the room I'm recording this video in right now, and you fill it up with helium. It'll take up the space, and assuming the door is properly sealed, it'll stay in the space until something allows it to leak out. The only thing that doesn't have to be contained by a solid are solids themselves. That's the tricky part. And and also you can know something, some unnecessary repetition. They literally just said to may displace oxygen and cause rapid suffocation. That was a good point, but they already said it earlier, so you can see this is a really long one. Oh, and also, just another point. What in this helium SDS, we are only talking about helium 4, the most common one. Helium 3, however, is not going to be discussed because it's a super rare isotope. If when I do a video on hydrogen, nitrogen, and oxygen, I may get to deuterium and tritium, but that'll probably be in another video, along with helium 3. Okay, so in green name, all helium, of course. Now, the thing that's confusing is this. Flush contaminated skin with plenty of water. Remove contaminated clothing and shoes. Get medical attention. Symptoms occur. Wash clothing before reuse. And clean shoes thoroughly before reuse. Well, that's a tricky part because helium is not known to be corrosive gas. It's not corrosive gas. Chlorine, on the other hand, or fluorine, or any halogen in its gaseous form is. So just keep that in mind. Skin contact is kind of puffery. Its contacted rapidly expanding gas may cause burns or frostbite. Now that's a different thing. However, it's pretty. It's you can't. I mean, normal labs, even cryogenic labs, it's really hard for them to make liquid helium. Reason is, helium liquefies at 1 Kelvin. 1 Kelvin. You heard me right. I guess it solidifies at 0 Kelvin, but that's anyone's guess because 0 Kelvin is an ambiguous topic, and there are some arguments that 0 Kelvin can't even happen in real life. And again, 1 Kelvin. I know you're like question mark, question mark, question mark right now, but literally, it's true. 1 Kelvin. Okay, now, frostbite is weird, and besides, try to warm up the frozen tissues isn't applicable if liquid helium is at 1 Kelvin. And how are you even supposed to make that stuff at your house? Now, you can see all of this stuff. Now, this is another thing. Um, in SDS'S, gases are often treated as corrosive, even if they're not corrosive. Well, at least that's what I see in this. Now, if you see melting point, it is awfully close to absolute zero. And it just boils too soon. And product does not sustain combustion, obviously. And if air equals 1, helium's density in gas is 0.14. That's why helium. That's why if you fill up a balloon with air or carbon dioxide produced by your exhaling, or pure carbon dioxide, and because from that experiment where you put vinegar and baking soda and you put a balloon over it, that will just stay in the ground. But helium will float until the ceiling because it is just too lightweight, and it'll rise up because lighter substances rise and heavier substances sink. Yes, another part of fluid dynamics. Okay, now let's look at the next one. SDS helium compressed. Well, they said it themselves. Now, this is another thing. The purity of the substance in this section is used for classification only, does not respect the actual purity of the substance applies, for which other documentation should be consulted. The highest possible purity for helium is 99 with a bunch of nines followed by it. You can't get pure. Literally, you can't. I mean, the closest I've ever heard anyone getting to pure is in IC chips, like integrated circuits. In those ICs, there's a block of silicon, a very small one called monocrystalline silicon, and it has a very high purity of 9999999. Like I don't even remember the nines. I mean, that's the highest I've heard. There's nothing that's 100%. 100% is just for classification. Always remember that. Now I see a bunch of this stuff. At least this thing makes a good point. Adverse effects not expected from this product. I wonder what this would say if I was doing this on gallium. Now, trade names is interesting. Helium balloon gas, helium filling away. Now, again, filling away, you might be wondering why it's that, but again, helium density 0.14 when equals air. Now, respiratory arrest is just a fancy word for suffocation. And then there's a bunch of blah 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 here. It's necessary, but still. Now, this makes a good point. Helium doesn't burn, and it's not flammable, obviously. But B, the reason that is because fire is actually a chemical reaction. For example, say if you burn sulfur. If you burn sulfur, it actually reacts with the oxygen in the air to form sulfur dioxide, which is something you do not want to breathe in, but still. And helium, as we learned earlier, does not want any extra electrons. It says that over and over again. So no burning because it doesn't want to be in a molecule. Of course, if you ionize it, maybe, but of course, no He2 plus. Atoms don't care for bare nuclei. Now, here's a bunch of stuff. Advice for firefighters, blah blah blah, handling and storage, blah blah blah. Secure cylinders, blah blah blah. Okay, now I'm now the rest of these are pretty similar. If you see neon, gas under pressure, asphyxiant, another thing. This is asphyxiant, liquid. That's probably a good point. I don't have the exact condensing point of neon, but it's definitely higher than helium. It's something that a cryogenic lab could be able to produce with some effort. Now with argon, the next one up, high pressure gas. If high pressure gas is the only way to store it, although it does kind of sound wrong, like, can't you just make it normally? Well, no, it doesn't work like that. Now, suffocation, yeah. Again, rapidly expanding gas. Same with plasma. which all these noble gases except for radon is really famous for. Oh, and besides, I want to say something interesting about argan. Um, like if you've ever went to the grocery store and saw these little like trays of salads, the salad tray, ignoring the food and the tray and the wrap, is actually argan. Argan is non-reactive; it is passive, and thus actually helps prevent food storage. Also, websites that sell element samples for element collectors are starting to are starting to put the samples in glass ampules that are filled with argon to prevent the stuff from reacting. Thinking of copper. Now here's a bunch of stuff. Gas under pressure obviously explodes when heated. Plasma likes to go wild, even though you don't want it playing. Now, krypton is something interesting. This one actually is a flammable thing. Now, I'm actually kind of confused by that because, again, krypton is a noble gas and, and flames are a chemical reaction. And, and noble gases do not participate in chemical reactions. Sorry, not chemical. Now, this one makes a better point. Just gas under pressure. Again, displace oxygen cause rapid suffocation because they're really big atoms by this point. Gas under pressure, yeah. Asphyxiant in high concentrations. Again, the possibility of sudden anesthesia. Now, gas under pressure, obviously, frostbite, contact with evaporating liquid, blah blah blah. Stay off of liquid nitrogen and anything like that. Now, I'm holding off on opening the radon tab just yet because I want to communicate something special with you. Radon is actually a radioactive gas, and it can sometimes leak in homes. So you should probably check out some of these 40s videos on radon. I'm just showing you the SDS's right now. Okay, now this is for radon. This one is about radium 226, one of the isotopes. Now, the reason it says corrosive is because I just noticed something about this. It's actually talking about radon dissolved in hydrochloric acid, which is pretty interesting because gases don't parallel with liquids. In case you've ever blown bubbles in a glass with a straw, you know why. Now, obviously, warning, this material should only be used by persons qualified to handle radioactive material. Literally, it's radioactive. Now, you can see all of this stuff. Ignore the corrosive. It should actually say radioactive. Then here's actual radon. And to note that radon is different from radium. Radium is different. They're similar and I think radon is a decay product of radium or the other way. Look, anyways, they're super similar. Now, this one is actually on the website, sort of like the Flint Scientific one on gallium, which is pretty interesting. Now, it's also called a radon atom for some reason. Now, you can see all of this. No data available because it's way too difficult, dangerous. Well, I don't know why it says wash up with soap and plenty of water because again, gases don't pair with solids, and that's why all the objects around you aren't going crazy because the whole atmosphere is made of gas. 70% nitrogen, 21% oxygen, and some other stuff. Now, The thing is, radon is also carcinogen, which is which does make sense because it's radioactive and produces ionizing compounds which can harm tissue. I mean, no, living tissue. Now, the one that's similar is this one, radon 222. If you see this one, it's super similar. This weird thing. And also, if inhaled, consult the poison center. Radioactive. You're literally not supposed to breathe that stuff. Okay, that's it for today. We have helium, neon, argon, krypton, xenon, and radon. See you later. Bye. Get off my environment, radon 222. Bye.